Hey, very good morning, guys.
Hey, hi, Shivam. Good evening.
I
Hi,
think
Shivam.
the 1920 people yet. I think 11 people are still missing. If anyone can have a messenger, if you can send some chat or something like that. We can wait for another 2-3 minutes and it will start.
Hey Shivang, good morning.
Good morning.
Actually, today we have AHM starting at 9 a.m., 9 to 9:30. So I was just thinking if we could wrap it up today by 9 a.m. and then adjust this half an hour maybe tomorrow or day after. Would that be possible?
We can do that. So, is it possible then? Is it okay with everyone if we schedule the call tomorrow at 7?
Yeah, let me check on that and then I'll drop a note. We'll coordinate with Lakshmi on that.
Otherwise, on Saturday, we can manage some.
Yeah, I think that will also be better because we will have some breather, right?
Yeah. Sure. I think then let's do one thing. I think Saturday will be better. So maybe we can reduce 15 minutes at the one break time and 15 minutes at the other break time. That should suffice.
Okay. Okay, sure.
Okay, we still have 7 less people. Okay, meanwhile, people are joining. I just want you to confirm me one thing so that we can. Can everyone see my screen, right? Second screen?
Oh, yes, Shivam.
Okay. So if you go to my queue, I have a file which I have uploaded inside project. I was speaking actually very low right now, Lakshmi. Okay, so guys, one thing I want is, can you check if you can access this folder or not? Can all of you open your Cloud Lab and say HDFS DFS hyphen ls slash user slash Lakshmi 1706 slash project and can tell me if you are able to view this CSV file or not.
I can view this.
You can do this? Okay, perfect. So the reason is because it's almost a 1.3 GB file, as you can see here. I'm going to use it for your project. Now, there's one challenge in reducing it by half an hour today. I thought to have more on the project discussion today, but that's okay. We can push it to tomorrow a bit. So before that, we have to still finish some bucketing portions, but this was something which was still going to be in today's session. So let me tell you the agenda of today's session first. So let me come back here. So what all we have discussed in fact in last session, we spent a lot of time in understanding Hive queries. We went into even some advanced Hive stuff to understand that how you can also do partitioning. Now we will go to bucketing, but we have understood that how partitioning can impact your performance. Can anyone tell me that why, in which scenario partition may not be a good idea? Gaush?
If we are having less data, then partition is not a good idea.
Any other place? Arun? Arun, if you're there.
Can you repeat the question?
The question is, in which places partition may not be a good idea? So we discussed about partition being a good idea, but now
If you have a lot of data coming into the regularly,
no, that is for partitioning being to be used, right? I'm asking where partitioning is not a good idea.
When we no need to like partition, like for example, we need to check only for Karnataka in India. There is only like product is in only Karnataka, and that time we no need to go for the partition.
Yes. Or I can define it a bit more. Maybe you have done the partitions with respect to country and state, but you're querying it on based on date. Then in that case, partitioning will not help at all. So your query should also be corresponding to your partitions, what you have done. Then only it makes a difference. We also understood what is a static partitioning and what is a dynamic partition. Alti, what's the difference between them? Aditi? If you can hear me, Aditi? Okay. Ishwar? What's the difference between static partition and the dynamic partition? Or you are unable to mute. Okay, just check it out at your end. Grishma? If you can hear.
Yeah, I can hear you.
Yeah. So what's the difference between static and dynamic partitions?
Um,
Discuss that. Okay, no problem. Girish? Girish or Ram? Anyone? Okay, this was simple, right?
I think static only saves in like I mean when we delete the data for static, it will delete completely.
No, that you are going to the internal table and external table.
Okay, sorry.
Ram, would you like to answer?
Yes. In static partition, we can specify what partitions we want to create, and we have to insert one by one. And in dynamic, it will create all the partitions by itself.
Correct. Perfect. So here, if you recall in static, we were giving the query that this is my query to execute it. But in dynamic, we are not telling that how to partition. It's dynamically partitioning once I tell that based on this column, go ahead and partition. That is called as dynamic partition. So is dynamic partitioning enabled by default?
No.
No.
It is never going to be enabled by default. Now, we have understood about this. Now, the next agenda, what we will be covering today and tomorrow, in fact. So today I will be talking about bucketing. That will be our first thing we will be discussing on. I will be talking at a very high level what is a UDF, not going in detail because you guys do not know Java programming, but I will still give you the at least the insight that how UDF looks like. And then we will be talking about some optimization techniques, industrial experience, and then we will be moving to case study. May not be able to finish today because as requested, the class might end up at 9 a.m. So we will be kind of pushing it to tomorrow sometime as well. And then tomorrow, the agenda would also be talking about a NoSQL DB called as HBase. So we will be spending a considerable amount of time to understand what is a NoSQL DB, talking about even HBase case and MongoDB at a high level. And then we'll show you a demo quickly on HBase, that how HBase sort of looks like. This will be finishing up tomorrow with the Hadoop agenda. Where we have spended NoSQL DB, we have sort of spent a good time over Apache Hive, Scoop, and all these components. Then we will be moving from the next weekend to Apache Spark. Okay, so that's basically going to start from your Saturday itself, so that we will be spending a considerable amount of time on Apache Spark. Okay. Now, let's start with our first discussion, which is going to be with respect to your bucketing part. But before I go to bucketing as well, let me also show you a few more things. I'm again not going to execute it because again the data set is the Amazon review data, for which I want to just quickly show you how generally we think about writing all these things. So what we also do a lot of times is we want to ensure that whenever we are working on dynamic partition, it should not happen that we are ending up creating like lots and lot of partitions as well. We want to restrict it to some entity. So for those things, what we generally do is we say that, hey, these two settings we are well aware of, but after that, hey, I don't want to go beyond 3000 partitions. So if it's going beyond 3000 partitions, maybe reject that data. I don't care about them. But 3000 partition is the limit for me. I want to go for. Or sometime I can also say, hey, I want per node, means because at every data nodes you can have partitions as well, right? So per node, per data node, I want 3000 partitions. So this is also sometimes helpful when maybe you just want to work on some sample of data, or maybe you think that maybe dynamic partition can create huge amount of scenario. I have taken 3000, but people have gone till like 5,000, 10,000 and so on, depending on a project. If they feel that, okay, it's not required that much, then you can go about it in this way as well. So this is going to be quite helpful when you will be working on your projects. Now, second thing is, if you recall, we have discussed about yesterday Amazon review data, right? Which I showed you that how exactly it looks like. So I'm just going to create the same table again. I'm going to call it as electronics column S3 partition year month. I'm creating it with reviewer ID, ASIN. Remember, this is something we have yesterday discussed. This ASIN denotes the unique product ID. Then we have a reviewer name. We have helpful, like out of 25, 20 people have found it useful. Then we have a review text. We have overall rating. We have a summary of the review. What is the Unix review time and so on. Now, what we are doing here is we are partitioning it now. So there's a slight difference with the earlier command. So earlier this year and month were the part of the data because it was a non-partition table. Here I'm saying that maybe I want to have a lot of queries with respect to year and month. If you recall, even in yesterday's session also, I did a lot of execution based on year and month. I even asked you one question. I asked you that, can you tell me that based on, let's say 2008, how many reviews came? In 2009, how many reviews came? So if I'm hitting those sort of executions, so for that, I'm just partitioning it by year and month. And then I'm also defining my location here, that from where I want to read my data. This is pretty simple. Now, how are we going to insert this data? Again, we have seen that already. This is just a quick review for you, that how you can actually do this. So you can say insert inside this table, define a partition. Then after that, from the non-partition table, define your things. You can say, hey, I want reviewer ID as in reviewer ID, helpful, summary, Unix time. And now you can also notice that I was having this data in Unix time. So keep in mind, it's not like that you blindly start working on these things. So you have to say, convert this to year. Otherwise, it will not know, right? If you recall the older data, I have only Unix time. So from there, I will take out the year. Similarly, for the month also, I will take out that from my non-partition table. So now, based on this, I will be able to derive my particular partition table with my year and month as the partition columns. Now, once I'm done with this, what I want to do is I want to quickly show you how you will be able to compare your performance now. So if you want, what you can do is with respect to your partition table, hit this query. So with respect to partition table, hit this query, like select overall your count asterisk as review count. Remember, 5-star how many reviews, 4-star how many reviews, 3-star how many reviews. So overall how many reviews we have from my partition table, where my year is 2004 and month is, let's say, January. So I want to see for January 2004 that what exactly is going to be my reviews based on that, like how many got 3, how many got 4, and so on. So if I want to do that, then basically I can hit this particular command and I will be able to get that. Now, similar way, I can do the same thing with the non-partition table. So if I have to do with the non-partition table, you have to hit this query. So this select overall my count asterisk as review count from electronics. This is non-partition table where I have to definitely from Unix review time, I need to take out the year, and from the Unix review time, I need to take out the month and group by overall again. So when you will do that, I have already done this exercise when I had worked on my side of the things. Remember, I told you it's a very huge data, almost like 15 to 20 GB of data. So when I did that for a non-partition table, it took me to execute on a very small cluster, somewhere close to 2 minutes to get this response. But when I did the same thing with the partition table, I was able to hit that in some 6 seconds. That was a huge, huge difference, which I got just because of this partition. So that's the advantage which I have got, though I have not shown you here because it's again a very huge data. I cannot even upload to your cloud here. But I hope you got the idea now how we go about all this. Everyone clear now from the partitioning aspect? This became even like a revision for you, and on a real term data, how these things looks like. Any question? Okay. Now, as the next thing, what I will be explaining you is the bucketing portion. What happens from the bucketing point of view? Let's say you want to divide the data with respect to reviewer ID, maybe on the same data set. Since we are talking about that, on the same data set, let's say I want to now do this on the reviewer ID. There's a challenge with it. If I want to do on the reviewer ID, the problem is it will end up creating so many dynamic partitions because it will become equivalent to total number of rows what we have in the data if it's unique. Don't make sense, right? Even your query will not have much better impact. But somehow I still wanted it to be divided maybe based on dividing. The reason was my original file is so big, I'm not even able to open it. It's that big. And it's better if I can maybe divide it into smaller files. Then again, but dynamic partition is not helping me. How about I can come up with some idea that I am able to still divide with a restricted number of partitions. What do I mean by that? So let's say I have the data set, something like 1 comma A, 2 comma B, 3 comma C, 4 comma D, 5 comma E, 6 comma F, 7 comma G, 8 comma H, 9 comma, let me just add any random thing. Okay, now I just added this. Now here, this data set has just 10 rows, just to take an example, but it could have even more, right? Maybe let me add, okay, this should be fine. So this is the data set with me. Now, what I am saying is, if I create a dynamic partition based on the first column, which looks like my ID column, then in that case, it will create 10 partitions for me. But using bucketing, I can say, hey, go ahead and create only 3 partitions for me based on reviewer ID. Now, how it's going to work in this case? So in this case, what it will do, it will say, hey, I'm going to place you only in 3 buckets. Means I have only 3 partitions with me. I'm going to place you with that. Now, what is the medium? What is the way I'm going to place that? So it will say, I'm going to call myself as, let's say, bucket 0, which means partition 0. I'm going to call the second one as bucket 1, which is partition 2. I'm going to call myself as bucket 2, which is my last one, because I have only 3. Now what I will do, I will do some computations to decide that which row should go where. So it will go to the first row. It will say, hey, you are 1, right? So what I will do, I will say 1 modulo 3. Okay, because I have only 3 places with myself, no more than 3. So 1 modulo 3 is going to give me 1, right? Means modulo means remainder. I hope everybody is aware. If not, just ask me. This is a remainder. So if you divide 1 by 3, your remainder is going to be 1. So in this case, it will say that, hey, I'm going to place you in my bucket number 1. I'm going to say 1, 3 here with respect to it. Now let's see more data. 2, b. So it will say, hey, go ahead and give me 2 modulo 3. Now the remainder is going to be 2 here. So it will say, hey, go ahead and place yourself in bucket number 2, which is going to be 2, sorry, this was 1, a, right? 1, a. So place this here, and here place 2, b in this place. Now after that you got 3, c. That means 3 modulo 3. It will return you 0. So place it in my bucket 0, which is going to be 3, c. Tell me where I should place 4, d. In the bucket 1.
First bucket.
Bucket 1.
Okay, perfect. Why? Because if I say 4 modulo 3, I will get remainder as 1. And now I will be getting 4, d in this particular file in bucket 1. Same way, I can keep placing. Now you may say, when I was doing partitioning, when I was searching for Karnataka, I was aware of that, okay, the directory will be somewhere written as KA. So I was able to identify that all the data related to Karnataka is in this directory. What about in this case? How do I know if I'm, let's say, searching for employee number 4, then how I will know where I have to go? It's same concept. Let's say you're searching for 4. It will again do this same modulo operation, which is like a hash operation. And it will say that, hey, 4, you are 4. I'm just going to do your modulo with it. So I got 1. That means this data must be sitting in bucket number 1. Go ahead and look at it there. So this way, I am able to quickly search the data as well. I'm still not touching bucket 0 and bucket 2. I'm able to use the same hash concept to be able to reach to the exact location where I want to go. This is the power of bucketing for you. So the bucketing, the way it helps you is, it helps you to restrict your number of partition whenever you may have to sort of do it maybe on ID column or something like that, and you don't have a clear picture how to go about it. So in those cases, bucketing will help a lot to kind of restrict.
Not on string fields.
I'm coming to that.
Not on string.
So strings, you will be having the, let's say there is a city column or maybe a name column, and let's say the name is let's say Noida. Okay, let's say a place column is Noida. So what it will do, it will compute the SKI of N, SKI of O, SKI of I, SKI of D, SKI of A. It will add all of them. Once it will add all of them, then after that it will do the modulo. Got the answer?
Got it. Okay.
So for anything, it could be either going to be integer, or it could be string. On both the sides, it will be able to perform this modulo operation and can restrict my number of partitions. First of all, everyone clear how bucketing works and how this is also going to be performance friendly?
If you're
Shivank,
looking for,
are you?
Okay, let's
could
go
you
on.
please let us know, Shivank, why or how do we decide the number of buckets needed to be 3, or how that number could be decided? Or is that a business requirement that decides?
It's a business case. Again, it depends on case to case how you want to. Now, let's say you have data set which have, let's say, 10,000 rows. Maybe your cluster size is small, not that very big, because ultimately they are all going to sit into different data nodes, right? 10,000, I have taken very small example, but just to take it up, let's say 10,000 is a big number, let's say. Now, in this case, maybe you say that, hey, maybe on one machine, if I keep 1,000 rows, it will be optimal to search. Means from the searching perspective. Let's not go beyond 1,000 in terms of in one file. So in that case, what you will say, hey, let me place maybe 10 buckets. 10 buckets seems to be fine here, because 10 buckets will go ahead and place me the data sort of, if it's a uniform, maybe in some places it can still go to 1,200. Maybe in some file it can go to 700 because it's the hash distribution, right? But still, it gives me a okay picture with, let's say I'm okay with somewhere close to 1000 to 1500 rows in one file, so that it can be easily searched within that file as well. So depending on those cases, you will take the call that how many, what is the size of the data would you prefer in one file for your searching?
Yeah, sure.
Yeah, I think there were a few more questions.
Yeah, I wanted to ask about this modulus and the ASCII operations. Are these predefined, or is there something that is configurable?
No, you will not do anything. This will be taken care by the bucketing algorithm, which is already pre-written for you. But yes,
Okay.
there are customizations possible, though it's not the straightforward way. You have to go and change actually the source code, which I have done it for one of my projects, not one, two of my projects. Basically where what the data was not even string format, it was a date format, and there I wanted a different logic. So what I did was I went ahead and updated that open source code. I compiled that code in my own machine, and using that I was able to change that some logic. So but it's never recommended to do that unless and until you really know how to play with open source community. So that's where I was able to do all those changes as well. So it completely depends like on the case, but you will most likely never be coming up with this scenario where you have to change it.
Okay. One more thing, can we increase the partition or say bucketing numbers based on the data volume? So today I decided to have 3 buckets. Tomorrow I want to add couple of them. Is that possible?
Yeah, you can easily do all that as well. In fact, I suggest you a better way, though it is feasible to do with alter command, but it takes time. What you're ideally doing is you're deleting your old buckets. And then don't you think if you change your maybe from 10 buckets to 15 buckets, don't you think your hash function have completely changed now? It's like a
Yeah.
redistribution of data. So in those cases, it's a better thing to actually either remove it and rerun the command, save it at different location, or there is another concept, though I cannot cover it here, but there is a concept called as consistency hashing. You can go and read about that. That is a hashing also used in Cassandra sort of frameworks, which is a NoSQL DB. So if you use that, it sort of creates like a ring architecture, and it can distribute the data very well within it, and the data movement becomes very less. So you need not delete and do that. Within the same, it will distribute in such a way that it will be very quick movement with very less movement of the data. So if you want, you can go about and read about that consistency hashing.
Okay.
Shivank, for example, I have only one partition. I have 5 buckets. How it is going to find the remainder here?
You have only one partition. So you're
Yes.
saying my data is divided something like this. There are 2 columns. One is C1, C2. The first level, I have a partition with C1, and C2, I have a bucketing. Means sub-partition is a bucketing. Is that your question, Manju?
Yes, Shivank.
Okay. So let's say C1 is, let's say, a state column. And inside that state column, maybe, basically inside the state column, I have like reviewer ID based on that I'm doing the bucketing. So inside that particular state, let's say Karnataka, now if I'm looking at the ID, which could be, let's say, Aadhaar number for Indian people, then in that case, what's going to happen? So it will know that, okay, you have, let's say, decided that for Karnataka state, I have, let's say, 1 lakh people. Let's say, I'm just taking a random number. So for 1 lakh, let's say you decided to divide it into some parts, like which have made it like 10K people per bucket, right? Let's say we have taken like this. So it will be how many? I think 10 buckets, right? Okay.
Yes, 10 buckets.
It will be 10 buckets. So now, since based on Aadhaar number, which is like a string, because your Aadhaar number is a B, C, D, something else also there. So based on that, it is sending it to 10 buckets. So let's say your Aadhaar number is AA1234. Let's take an example. So now in this case, what it will do, it will compute the ASCII of what? AA, even for 1, 2, 3, 4, because it's also will be treated as string now, not as a number. Now it will be computing the ASCII. Let's say it got it to, let's say 564, just taking an example. Now I have 10 buckets. So what it will do, it will say it modulo by 10. So what is the output I will get here, Manju? What should be the output here? Manju?
4.
It will be 4, right?
4.
Yes.
It will be 4. So now when you are inserting it, then also I know that I need to go to my B4 and insert my data. I will have a bucket from B0 to B9, right? So it will know that, okay, go to my B4 and insert the data. While searching for it also, don't you think it will be using the same logic? You will say, I'm giving my Aadhaar number. It will compute this number quickly from that. Once it will get the number, it will do a modulo with 10 and give you 4 immediately.
Yes.
Right? So this way it will search for you, because while inserting and while reading, we are applying the same function, and that function will always give me the same consistent result. That's the reason it will know that, okay, first I came to my Karnataka state, and after that apply the logic to see that which bucket it will be. Now in B4, maybe you have 10,000 records. Now in that B4, you have to still go and search for 10,000 records and find out this value, but it is still better than in searching from the 1 lakh rows, right? So you will still not touch those 90,000 rows at all.
Shivank, what if you have set the partition to be only 2, and when you do 564 modulo 10, the remainder is 4?
Okay, first of all, this condition is not possible, right? If we have set the if you have set the number of partition as 2 for the bucketing, then while reading also you will be doing modulo 2 only. Your hash function is decided based on the total number of partitions only, right? So if you have, while creating the buckets, if you have said I'm creating 2 partitions, then the formula will always be modulo by 2 while writing and while reading both.
Yeah, got it now.
Sure. Any other questions?
Shivan,
Yes, sir.
how can we make the bucketing on the numerical values?
How can we?
Make the bucket on numerical values.
On the numerical, we have just seen this example, right? 1 modulo 4, 2, sorry. Yeah, in this example, I think I took 3. Okay? Yeah, 1 modulo 3, 2 modulo 3, 3 modulo 3. On string, it was in fact tricky because I have to do the ASCII, I have to add them up, then whatever number I get, then I do a module. On number, it is that it's.
Yeah, but they are landing in the different buckets. Suppose I want to be in their one bucket. I want 1 to 4 in one bucket, 5 to 8 in second bucket, and remaining in the third bucket.
So that is what I just answered. I think somebody who asked this question as well, that yes, customization of this algorithm is still feasible. You have to go and update the code in the open source community, which is written, because the algorithm, the way it is written right now, they have given you some specific which you can use by default. But if you want to change that, yes, you can go and update that, and then it will start working based on your customized logic as well.
Okay, sure.
But then you need to be good in like changing the code, how to compile it in your environment, and basically then you will be able to only perform this.
Okay.
Shivank, can I also consider that this process of converting ASCII values and adding up all, that will also be done in a hash function by default?
They don't require hash function, right? So you can think of it as going in the different function, which is used basically to get all these ASCII value additions and give you the result. Once, so it's like different functions. Actually, if you go to the open source community, because I've read this code already, I can tell you that this is a separate function they have written, which is like getting a number value. And then if you get that, it passes this to the hash function where it goes ahead and performs the modulo operation.
Yes, Shivank. Yes.
Any other question from anyone? And these are very important concepts, guys. Very, very important, because if you really want to, when you will be going into your working zone of Apache Hive or in your project, you will find that Apache Hive is getting used a lot. And when you're working on this Apache Hive, you will notice that this optimization techniques like using partitioning, bucketing helps a lot. I will tell you a few more, but this is like a starting point for you. You should definitely be very good in this. And remember, in Apache Spark also we will use Apache Hadoop. So we are already kind of into that zone. Okay, I'm moving to the next part now. So we have seen now with this. Let me show you maybe one example here itself, and then I will show you one example with running code also. So first thing is, if I want to enable buckets, I have to set the bucketing as true as well. That's number one you should be aware of. So I have to say set hype.enforce.bucketing is equal to true. Otherwise, your buckets will not be created for you. That's number one step. Second is, let's say I want to create now this partitions. The way I will be doing it is, let me show you. So look at this. So I'm going to say, let's say create external table if not exist. I'm just giving some name to it. Look at this part. Reviewer ID, SN, all this is fine till Unix review time. I'm saying I'm going to partition it by year. I'm going to do a sub partition by month. Within that month also, I want to create one more level of partition, which is a bucketing, and I want to do it with reviewer ID. And the way we define it here as syntax is called as clustered by. So I will say clustered by, I will say reviewer ID, and then how many total buckets I want? 4 buckets. So this number will be given by you. And then you can also define in which location you want to create it as well. So this way, when you will be creating it up, this is going to go ahead and create a table for you, which is going to be a partition plus bucketing table. Okay, this should be clear to all of you. One thing to note here. Notice this reviewer ID is also a part of column. Is it making sense to everyone or not?
Yes.
If you even see this example here also, when I did a bucketing on one, I had this data one also present in my bucket one, right? Because I have to. It's like there will be multiple IDs going to come in one file now. So that's the reason this should be in both the places. That slight difference you need to keep in mind while working on your syntax as well. Now, if I want to insert this data, it's pretty simple. There, the syntax will not change at all. So I can say insert into this particular table, partition is year month, select all these conditions from your non-partition table. As you can see from here, nothing have changed. From insert side, everything is still remaining the same. Only difference comes when we are defining the, basically creating the table. Then only we have to define that, hey, go ahead and basically create the clustered by, and how many total clustered by I have to define this. Clear, everyone? Any questions on this?
Shivank,
Yeah.
values in the buckets could be kind of a list or a list of key value pairs. Will that be? Is my consideration correct?
I'm not clear on your question. When you say it's going to be
How values in the buckets can be stored?
how values in the buckets will be stored. In this example,
Yeah.
look at this part, how it's going to be stored. So if you look at this one, what we have done, number one, we will create the first level directory. So let's say we have /user /cloud data. Maybe after that, we have created a directory called as Amazon. Now inside Amazon, there will be first directory called as year, right? So maybe for 2018, there will be one directory, right? Similarly, within even there will be /user /cloud data /Amazon. Maybe there will be directories for 2019 and so on as well. Now, within this 2018 also, we will have the directories based on month. Let's say we will have a directory for January, right? Similar way, we will have even in 2018 itself, we will have a directory for February and so on, right? This question is clear. Now, within this Jan also, then what will happen is I will have these buckets. How many buckets I'm saying? 4 buckets. So there will be 4 part files, part 00, Then everything will be same here till Jan, and then again it will be written as part 001 and till part 003, part 002, part 003, 4 buckets. Now, so for the January data, all the January data what we have, whatever reviewer ID we will be having, for those people, it will be sending the data in part 00. So it will say, okay, so let's say for January, I have 1,000 people. Okay. And I said that I want to put them into 4 buckets. So in that case, for those 1,000 people, based on the reviewer ID, it will do the modulo with 4 and will keep on placing the records here. Like maybe it will say for maybe reviewer ID, placing it, taking it up. Okay. Similarly, reviewer ID 2 may be going here, depending on the modulo what you will get, you will keep on placing. Part 00 will denote your bucket 4, part 001 will denote your bucket 1, and so on.
Clear, very clear, Shivam. Thank you.
Anyone else having any question on that? Okay, Aditi, there is things coming from your side.
Oh, sorry.
Okay. Now, any other question on this, guys? Okay. Now, what we will be doing, let me go back and we have a table which was a partition table. In fact, I think we have already created a table called as bucket 1. Let me save this. Come out from here, go to my editor, which is Hive. Okay. Yesterday we were using, I think, the database. Use database. Can anybody recall that? I think Shivang won, right? Anyone remember that?
It's in Shivang.
It's Shivang.
Shivang or Shivang?
Shivang.
Shivang, no.
Okay. So let's see this. I can quickly see my tables also inside that. Show. Okay, I have created a product tables here or not. I just want to see that. Oh, I have created so many tables. Okay, I have a product table. So let me just quickly see that what all data I have within it. Maybe I can say describe. Okay, here I have sales transaction 1 and so on. Okay, that should be fine. So let's say if I talk about this same products table, in this case, what do you think should be my, how my data should be sort of bucketed and let's say going to be partitioned? If I ask you this question, how you will go about it?
Via product ID.
Product ID, okay. That makes sense. We can do that with product ID, right? Now, what about, in this case, if I have to ask you, let's say with respect to your partitions, any column which makes sense, which could be used for partition as well?
Product category.
Huh?
Product category, perfect. This seems to be a good design because then I can see that, okay, based on this category, how my things are being working on. What about price? Do you think this could be helpful somewhere? Think about Amazon.
Yeah, if we can define the range of the partition, like price less than $100 or something like that, then it will be useful.
Correct. If you have seen the Amazon website, have you seen they have a filter? Do you want to buy a phone less than 10,000? Do you want to buy a phone in this range? So if you can define that, Actually, that all things happens with the help of Hive only. There are an Apache Hive for that. Can I give this as a homework exercise for all of you to come back maybe with this particular part, creating partitions with category and non-partitions, which is with respect to your uh, bucket with respect to your product ID, and maybe you can take a call how many you want to place it up. I will give you this products data file as well. So with this, can I expect all of you come back tomorrow with this exercise? It's going to be a small exercise, but I want all of you to do it. Okay.
Yes, sure.
Could you repeat it, please?
The question is, we have yesterday created this product table, which was a non-partition table. Now, what I want you to do as an exercise, you have to enable your dynamic partition. First of all, based on, we have discussed the category column. That's one thing, right? Then after that, I want you to bucket this maybe based on the product ID sort of thing. So that's one thing. Second thing you can also do is create a partition table with the pricing. Pricing, similar way how Amazon follow. Like you have the pricing less than 10,000, maybe greater than this. In fact, what I want instead is, let me come back here. I want something very similar to Amazon. Okay. So first thing is like, let's say you have the category which you can go about. This you can use it for partition, and then you can use the other product ID for your bucket. Take your call how you want to do it. Second is, I will give you this the problem statement. You tell me the solution from it on your own. I want something like this. Let's say there is a phone category. From phone category, okay, it should tell me that, okay, give me the pricing, let's say less than 10,000. Give me something which is between 10,000 to 20,000. Right? Same way, maybe I could have laptops. For laptops also, I want again this same sort of thing with pricing. Clear? So I want this to be sort of created just like how Amazon have it. Clear? On the problem statement, everyone?
But it is price, right?
It is? Yeah.
So 10,000 is price, right?
Yeah. So you need to do some changes in your SQL query to make it happen.
So why we need product ID?
No, that's the first problem. First problem was different. Second problem is different.
So what is the first problem?
The first problem was just to have a simple partition table with category and the bucket with product type. Straightforward. Okay. Nothing tougher. Okay. Second question is more like a case study problem for you.
Okay. So price should be bucket or partition?
Yeah. So the price, I want you, I leave it to you to take that call. Whether you think your bucketing will help you, or do you think partition will help you? I gave you just this problem statement. Like, let's say you have joined a client, let's say to have seen some client came who is just a new beginner to maybe e-commerce domain. And they said that, hey, just can you notice that in Amazon, they do this filtering when you go to your phone page, they say that, hey, would you like to have this filter based on less than 10,000, 10,000 to 20,000? I want something like that. And my data set is huge. How you will solve that problem? Right? For their phone, for their laptop, for their other items, how you will solve this problem? Clear on the problem, Ramna? Everyone?
Yes.
So at the first level, it's very clear that we have to do partitioning for phone, separate out phone from laptop, from all that. And then you have to think whether I should be doing the bucketing for it. First of all, you need to also see how to bring this, because your data set will be like 8,000, 7,000, 6,000, 15,000. How you are going to create all that situation also, you need to think about it. But this is like a real-time problem statement which you have to solve. Any question, first of all, on this assignment from anyone? Perfect. So now since we have understood about this whole thing, let's go to optimization techniques.
Shivan, a small question. Hello.
Yeah, please.
Yeah, like I have a small question. So, for example, there is a product and it is partition and on based of price and based of brand as well. Okay, so the brand in the sense the partition will go into the brand folder, and price in the sense the same product will go into the price partition folder. So like it is like the same product is going into two different folders, right? The same row or same value, it is going to two different folders. Isn't it like the data is redundant, like multiple times it is saying?
Let me place this question here. You are saying that you have a brand here and you have a price. Am I right? You're saying that?
Yes, yes.
Okay. So first of all, let's say you did the partition with respect to brand. So let's say your brand is, let's say Samsung for, let's say, mobile. Okay. Now, once you have created Samsung brand, don't you think all the data related to Samsung have already decided to go in this directory only?
Yes.
At the first level. So then there is no duplication of data which will happen, right? Because it have already decided that Samsung will go only to, because at the parent directory also you need to think, right? You're only getting the data for Samsung in one directory. Only on that only you are doing your next bucketing or partitioning.
Yes, yes.
Okay. Let's talk about optimization techniques. Now here I need your complete attention, guys, because this is going to be sort of really, really important for you to think across, to know how this whole thing works and so on. We already know Apache Hive is awesome, right? It can solve your queries, it can do everything up for you. And earlier when it was created, it was also created with an intention that we will be converting your SQL code to MapReduce and return you the output. This worked really well from the starting point of view. But later, people thought that let's make this as a one-stop solution for all the SQL queries. Means it doesn't restrict only to the MapReduce. MapReduce remain only as one of the thing, but there are so many things which you can also perform to it. Now, what you can do here is there are two frameworks what you have which you can use. One is your Tej framework, and second is your LLab framework. I will talk about both of them in detail to you. What happens with both and how they work. Number one, when I say Tej framework have become now the default factor for your Apache Hive. If you are still using Apache Hive with MapReduce, you are doing completely wrong way of working. Okay. The problem is MapReduce do so much of input output operation that even for the batch processing, it is very slow. On the other hand, if you enable Tej, which your administrator have to do and set it up, if you enable Tej, then what's going to happen is it is going to go ahead and execute your batch queries really, really fast. What happens here in Tej? In Tej, it do not write the intermediate data to your hard disk. Instead, what it do is, it is creating like a graph. It will say, hey, okay, you have written a code. I know your code that these are the steps you have to perform. You will load the data. You will run this as the first code. Then after that, you will do this. After that, you will do this. I will create a graph for you, and you can keep transferring the data in that graph itself. Means you are no more writing the data output now back to your hard disk, but you are just continuously transferring your data back and back to the other graph format. Once you do this, it will, since you are not doing any input output, it reduce your cost for batch processing up to a very great extent. That's one of the very, very interesting thing what they have brought up. In fact, I have seen 50x faster performance when we have just changed the framework from MapReduce programming to Tej. Now, Tej and Yarn can work even together. It's not like that you have to use basically this thing separately. And setting it up is very simple, though I'm not going to talk about setting up because this should be set up by your admin. But I can tell you, if you want to check in your cluster that what is your current one, you can say set hive.execution.engine. If you execute it, it will tell you that what's the current execution engine. If you want to set it up to Tej, you can say set hive.execution.engine is equal to this. That's it. If you just hit this, you will be getting your Tej now. And remember, it's case sensitive. If you type T capital or something, you will end up with errors. So if you use the Tej execution engine, and now you can query the things with the same way, the way you were doing it up, it will run your things really, really fast when it comes to your batch processing. That's number one. And like I said, Tej became the de facto. I'm working with Facebook right now. Facebook is also using Tej for a lot of their processing part when it comes to batch processing. It becomes the default engine. Nobody used MapReduce there. I know few companies who are still using MapReduce. I'm not saying that they have completely moved it out, but a lot of companies are using MapReduce because of lack of knowledge also. When I joined them up, I kind of get surprised that they're still working on MapReduce, and I tell them that we have to change it. And after that, they also save a lot of cost because when your processing time is lesser, your costing basically will also sort of reduce as well a lot. Second interesting point about Tej is, let's say you have two different programs running, and if you have, let's say, Tej and Yarn enabled together, so both of these different code may have a common object. Maybe they both came to a conclusion where they both may be creating a common object as an intermediate output, and after that the processing would go different. So in that case, it will not create a separate objects for both of them. Earlier with Yarn, what was happening was that, okay, for program one, if you create an object, program two, you create an object, maybe both are similar nature, still it will create both of them separately. But what Tej will do, it will ensure that if there is a common object like that, and if it identifies, because it will also be connected with Yarn, so it will have the knowledge about it, then in that case, it will not create that duplicate object. It will just reuse it altogether. So that's also another advantage what Tej sort of brings up. And when you're working on such a huge cluster, this will save a very huge amount of storage cost or the memory cost also for you, because now you're kind of using the common factor around it. So that's one thing to keep in mind, that whenever you're working across with your batch processing, think about Tej. Second is LLAP. Now, what is LLAP going to do for you? The full form, if I'm not wrong, it's live long and process. But some people also call it as low latency analytics platform, something like that. So I don't remember the exact one, but yes, people also call it a different one. Now, where this is helpful? This is helpful when you want to run some interactive queries, means some data science analytics sort of queries, ad hoc queries. So let's say like people who are already working like a data scientist, they might be aware the way you write a query, you will write something, then you will just add or delete something in the same query, and small change and want to see what happened. Then again you will do the small change to it and again just want to see what happened. If you are doing it with the Hive MapReduce framework or even with the Tej framework, what will happen is for every time it will re-execute. But what LLAP do for you, it have its own daemon. And what it do is with daemon, once the query reaches to the daemon, it will go and check, hey, do I already have this data? It cache it in the memory itself. If it have the data, it will go ahead and use it. It will not basically go back and check that, okay, let me send this code or that code. It will go ahead and start executing it. So that way, since it do the caching component and all, it will make your interactive query very, very fast. And that's one of the core reason why Impala is gone now. Nobody's using it. So if you know LLAP, even Apache Spark also is one of the reasons. I will come back to that. But even if you don't want to use Apache Spark, if you use LLAP, you don't need to go ahead and use any other thing across with it. It will basically help you to solve the problem across with it. Now, a lot of people do this. In fact, I do this. When you configure these frameworks, what people generally go for is they can say that, hey, I don't bother about LLAP because maybe I don't have any analytics query, and they just use stage frameworks. Nobody use MapReduce, so let's forget about that. So that way, if you have more of a batch query, then they say that, okay, I'm not interested in your LLAP at all. I'm only interested maybe in the stage. Second option is what I sometimes do is that whenever any Hive query hit, I can say that, hey, first execution should always go to LLAP. Okay, first it will go and check in LLAP daemons, whether it have a data, whether it's cached, whether it can be broken up. If we do not find it, immediately send it to pitch. That's the second one. Where you're not sure, you can actually configure it in this way. Third way is, sometimes, though it's a little tricky, I have customized a lot of things there to make it work, but I have also done it that for some criteria, when my query is following some criteria, I can say that, hey, go ahead and hit LLAP. If it's following the other side of the criteria, go ahead and hit stage. Means you can have all these frameworks being enabled together. That's the best thing, right? And you can actually, based on your conditions, you can take a call that how you want to sort of send all these things. Means you can set up all these things part. And you will be surprised how much time it will save for you. Means I have seen LLAP, especially for the analytics, working much faster in comparison to Sage. Like some query which could take maybe 90 seconds for me in LLAP, in Sage, may end up just taking 50 seconds with LLAP. So that's basically the power what you get across with respect to LLAP. So that's where the first thing I always look for LLAP, and then I go to Sage. And it also depends on the problems what I'm looking for. And again, setting this up is pretty straightforward. You can just say set hive.execution.engine is going to be equal to LLAP. That's it. You have to only say this and it will start working. Now, though nothing to talk here, but still I can tell you just quickly few details here. If you have to set up some configurations, you can say, let's say hive.llap.execution.mode is equal to all. You can set this. If you do this, this means that Hive will always run all your queries using LLAP, okay, if possible. And if LLAP is unable to run a particular query, then it should be processed by Sage. This is the way I just explained you some concept before, right? That you can, I have done all these sort of configurations. So this is the configuration settings for it. Similarly, you can also set the same property to only, okay? Instead of all, you can say only. Only means that it will not send it to Sage at all. Okay, so if LLAP is going to fail, if it finds LLAP, it's okay. If LLAP is going to fail, it will not fall back to Sage. In fact, it will throw you an error. Okay, so that's what's gonna happen. If you send it to auto, there is also a setting which is auto you can provide. In that case, you are letting Hive to decide whether to use LLAP or the Sage framework for particular query, whichever you're sending. So Hive will take a better call because it have its own optimizers and catalysts. It will figure out from that. Similarly, if you say it none, then in that case, Hive is not going to use LLAP at all. All the queries will go into the Sage in that case. So this is a small setting which I've used basically to configure. Definitely there are much more to it, but just I thought to at least give you some insight around it. Everyone clear on this?
Shivank, all the frameworks which you told now, the two frameworks, Stage and LLAP, are with respect to batch processing.
Batch processing, Stage framework, LLAP for analytics, ad hoc queries, interactive.
Interactive. When there comes a streaming of data, will there be any other framework as such?
Yeah, for that, we will not be using this. Then you can either go with the Spark streaming, which is available there. That will be helping you with this. Yeah. Like we connect Apache Kafka with Spark streaming in those cases.
Yeah, yes.
So Shivank, LF can keep the data in cache. So what would be the duration for the cache? Can we reset the cache also?
There are commands for it, though I'm not going into that detail, but yes, there are commands. You can even reset, you can, you have to just hit those commands which are specific to a lab and it will take care of those things as well.
So for caching, what data exactly this LF is using? Like some Redis, something?
I can give you a small insight from it. Maybe you know how to write interactive queries, right? Let's say you have hit the first query, which did some computation. Then what it will do is the data which it have done, the intermediate steps, what it have done, it will save it into its cache for now. Let's say the second query you hit it. Now you did just a slight change to it, very slight change. And maybe intermediate results will still remain the same. And then after that, in the last, maybe something have changed. So in that case, what will happen? Instead of recomputing the whole thing, it will reuse that intermediate output from you because it have cached it. And then after that, whatever the changes required, that execution it will do and return the result for you.
Okay.
Any other question on this?
Shivang, can you once again explain how Tej works internally? You talked about graphs, right? So I want little bit more explanation on that.
So think of it in this way. Let's say the first step is that you are loading the data. Okay. Second step is that you are applying a mapper code. Third step is that you are doing a sorting. Fourth step is that you are doing a reducing. And the fifth step is you are writing the output. Now in MapReduce, what was happening? In MapReduce, you were loading the data to Mapper. Mapper was doing its computation. Then it was writing it back to the local disk. Remember that? That it was happening. Then
Yeah.
sorting was picking it up. Now here, once the graph is defined, it will not write it to the disk. It will keep transferring the data from one end to another end in this same one. Like it will keep it in the memory. Think of it like mapper output. It have kept it into the cache RAM only. And as soon as the sorting step happens, means you cannot ignore the anyway network transfer. But once that is done, you're just keeping all the data in the memory itself. You're not doing anything, basically bringing it back to the local disk and again loading it back. So all the intermediate steps what were there, you're not basically doing any disk input output operation. Clear on this part? In fact, this is very similar to how Apache Spark framework work as well. When I will move to
Yeah.
but I will show you a real example how it goes as well.
Understood.
I think Girish, you mentioned that you moved to Impala, right? Have you attempted this framework before that? Girish? Okay, I think you cannot hear. Now, in fact, anyone from Girish group who have also attempted Impala?
I think it would be in his previous company, not sure.
Okay.
But Shivank, what I wanted to understand, you talked about Tej works internally as a graph system. So that sounds really interesting to me. How and where that is maintained, whether it is maintained in memory or how exactly does it operate internally?
It keeps like a metadata, just like how
Okay.
name keeps it like a metadata, right? It also keeps it
Okay.
like a metadata information. And then while executing part, it will keep it in the memory. Once it's done, again, it brings it in the hard disk metadata. Think of it like name node fs image.
Can you repeat the last part, Sean?
Think of it like name node fs image and edit logs.
Okay.
You are keeping the backups, right? So whenever required, you were bringing into the RAM, means you have a copy in the RAM, but you were also keeping in the disk so that if something goes wrong, I can again load it back. So that way it works. Same way.
Okay. So it is more when you said graph, I just wanted to understand whether we are talking about directed graph and a graph theory here, but it is, as I understand now, it is more like a pointer theory. Like it keeps pointing to that object in the particular memory location.
Yes. That's where it has a slight difference from Apache Spark. So Apache Spark also you have a tag which we call it as lineage, which I will be talking in detail once I move to Apache Spark. But it's not a pointer there. It's a little different from this. I will talk about in Apache Spark in detail.
Sure. Okay.
So yeah, these things you guys have to keep in mind. Like I said, generally I have seen people doing mistakes of using MapReduce because they're not aware of these things. And major of the thing is because these things are not even mentioned in much of the documentation in detail. These things are very new sort of things what have came up in the market, and the books are still old. They are still using MapReduce stuff. If you keep on taking up those books, they will not talk about these things in detail. So that's the reason people are still preferring this up, ending up wasting their own time as well as money as well on this. Now, second optimization problem is ORC format. Let me talk about this. What is this one? A very useful format when it comes to your Apache Hive. In fact, if I'm not wrong, the full form is optimized row columnar format. Now, what it do is, it is going to store the data in a columnar way. Okay. Now, what is the columnar way? Just ignore it till tomorrow because I will be showing you in HBase also in detail that how the columnar storage looks like. Think of it for now in this manner that in your RDBMS, when you store the data, it is in the row major order. Like with respect to the rows, you keep on putting the data in the same sequence. But when it comes to the columnar way, you're storing all the column data sort of together. So let's say column 1 being kept together, column 2 being kept sort of together. Now, when it comes to big data, this becomes very useful because let's say when you're hitting your query on some specific column out of thousands of columns, then you're not touching all of the data. You're just going to that specific column 1 or column 2 sort of place where it is stored and you are seeking it up. So that way you are reducing the seek. It's just like in Hive, we have created the partitions in buckets. Think of it almost in the same way, how it is behaving right now. So that way you are able to save a lot of things. Second other advantage what you get is, let's say you store all the column 1 data together. Now all the column 1 data, let's say if it is name, then I know that all the names will be of string data type. Now, since I'm now having a homogeneous data all together, then when I perform the compression on top of it, then in that case, that compression will be far better in comparison to when I was keeping it like a heterogeneous data. So that is one of the big advantage what ORC brings up for you because of the storage in form of the columnar way. And it also have something called as stripes. Ignore that, but basically stripes, if we have to talk about it, kind of store the data like column 1, column 2, column 3 of 256 MB like a batch together. So it's kind of keep the data in those stripes, or you can say batches of the data, which also makes the reading very fast. Again, think of those stripes like a partitions, right? You have one partition, partition 2. So whenever you have to search, maybe you will know that, okay, think of it like a bucket. In fact, like in bucket, you know that using the hash function, my data will be sitting in these buckets. Similar way, when you will have stripes, though I'm not going in detail because otherwise we have to talk a lot on ARC internally how it works. But when you have those stripes, so basically what happens is you know that, okay, my data using some hash function will be sitting in this particular stripe. So I'm not even touching the other stripes at all. So again, like a bucketing concepts, it will be kind of only going to a particular batch of the data where my exact location is. So that's another advantage what you get when you're searching it up. So this ORC format, you should be using it, in fact, instead of using any other format when you're working with respect to Apache Hive. Keep this in mind. This is again a very important factor. It helps a lot. Specifically, Hive is very much optimized with respect to the ORC format. So if you are storing it, processing it with your ORC, you will see a huge impact in your performance. Not just a small impact, but a huge impact in your performance. So this is going to be another helpful thing to keep in mind. So even what you can also look at it, if you recall that Amazon example, I created a table of partition there and I was working on it. I did the same thing with ORC, though I cannot basically upload the data here and show it to you. But when I did that, the performance was multi-fold, like almost like I got some 10x better performance in comparison to when I did the same thing with TextMate. So that's what, even if you're doing partitioning or bucketing, but still do everything saved into the ORC format. Specifically with Hive, it's going to be very helpful. Keep it like a default format. Don't use a default format which is given to you. Change it to something else. Now, another one is Parquet format. This is also pretty good. Parquet format. Actually, there was some paper written in Dremel. If you want, I can give you that link of the paper also. You can go through it. That have basically led to this distribution. What it have done is it basically was created keeping some complex data structure in mind. And basically, whenever you have nested sort of structures, it's pretty helpful. And what it do is it have the flexibility that you can do the compression and encoding based on the column by basis. Means what it means is, let's say column 1, you can say I want to compress it in this way. There are different kind of compressions also, or encoding also. Like you have a snappy compression, you have different compressions as well. So you can say I want to compress or the encode this data maybe in this particular format. I want to compress and keep the column 2 into this. So at a column level itself also, you will get that flexibility to do that. You can choose your compression schemes how you want to. And what also happens is when you're writing the data in a Parquet format, it also writes the metadata as well, which it keeps it in the end. Like it will also keep the detail about that data itself. So now what happens is when you're writing it, you can write it very quickly, and at the same time, now since you have the metadata, the reading also becomes fast because now you know where everything is sitting. And especially when you're working in a distributed fashion, what happens here is that since you have that metadata, it will know that, okay, my data is sitting in which nodes, and accordingly you can query it very fast. Again, I'm not going into these things very much detail. If you want, you can go and read about ORC and Parquet on the other side. My major focus right now is to give you some high level insight about these and to tell you where these are specifically going to be helpful. Now, Parquet you can also use with Hive, but from my personal experience, if you ask me, this is more helpful whenever you are doing some vectorized kind of operation. Vectorized kind of operation, think of it like when you work on AI sort of things, data science activity. So where you can keep all the data like a list format and sort of working on it, like some ML, let's say you're working on Spark ML or some sort of data science activity, that's where this is very helpful. And specifically, if you ask me, this is more preferred with Apache Spark because that's where actually we use or we convert the data like an array of rows, something like that. When I will move to that, I will show you exactly. And there, Parquet is much more optimized in comparison to anything else. Even it is much more optimized than ORC in that case. So whenever you're working like a vectorized part, it's highly useful to kind of go with this Parquet format. Third optimization technique, which I will tell you, is to read the data in vectorized format again. Vectorized operation, I should say. What is this? Generally, what happens is, let's say I say that, hey, go ahead on this column and add +2 to it. So what will the way you will go? You will say, hey, let me say row number 1 +2, row number 2 +2. You're doing it in a sequential format. Instead of that, maybe you would like to do all this operation all together on a batch of data altogether. Means I'm doing this all together to it. So that is something you can do it as well in your Apache Hive as well. So maybe that set of parallelism, you will bring it very quickly, even on that set of data what you have. And this is very popular. In fact, if you're coming from AI world, you must be knowing about something like Matplot or maybe Octave. These are like really good in doing all this part. Uh, and this is very simple actually also. When you want to do that, you have to just say set, just like how we were setting these things, right? Similar way, you can just set it to true, like hive dot vectorize dot format, something is equal to true. It will enable your vectorized format. And then when you will perform those vectorized operations, like you're doing, let's say some AI stuffs and all that, you will find it's really good performance in comparison to this. Almost like 60% to 70% performance improvement you will see when you just enable this setting to vectorize, because now it started doing more parallelism, doing it on the batches of data. it will be much faster and return you very quick results around it. So these are some techniques which you have to keep in mind when you are working across with this. Like number one, I told you to choose the right framework. Never ever think about using MapReduce framework. Think about Taze and LLab. Second thing which I told you is think about using the better file formats, ORC, Parquet. If you're working on Apache Hive, I would suggest you to go with ORC. That will be really good and good performance friendly. If you're working on vectorized operations, maybe you can think about Parquet with Apache Spark sort of scenario. Third is enable your vector. If you are doing some vectorized sort of operation, like which you think it will be more sequential in nature, like adding off some number to all the rows, then maybe do it on a batch of data. For that, just enable your vectorized setting, and you will see again almost 60 to 70% of better performance time frame there as well. So if you keep these few things in your mind, this will help you to optimize your Apache Hive up to a good extent. Any questions? And let me tell you one thing as very openly. I might have given you just maybe 5% of the optimization techniques because of the time constraint as well. There are so many means because I have worked on so many projects across everywhere. Whenever I was working, I got across to some of the other issues where I have to think about optimizations and kind of work out it. What I did was I just sort of recalled some of the major things which I always keep in mind while working on it and kind of talked about that. But when you will be working also, you may have to learn different optimization techniques as well. So like I said, I just gave you a very small, you can think of it like a small drop in ocean. I just gave you that much. But this is huge domain. Like I can keep on talking only about the optimizations just for maybe 2 days continuously. It's such a huge domain to think and talk about. But if you keep even these basic things in mind, you will be able to really do well in the Apache Hive queries, and thus you will save a lot of cost as well. These are the general things which generally the senior folks are very well aware of. Generally, junior folks are not aware of in the starting because these things are not mentioned as such in books or documentations as well. So you will get to know while working across with this. Any questions from anyone?
Yeah, Shivang, Girish this side. Can you show us a snapshot of the book that you wrote on Cloudera?
A snapshot of what?
Book you mentioned right in the first class that you wrote a book on Cloudera.
I think I showed you in yesterday or day before yesterday class itself.
Okay, maybe I was in. I missed it.
Using it again in my Spark. So if you were there and day before yesterday, sometime you have to move out because of meetings. Sometime you mentioned.
Yeah. Oh, okay.
I actually showed it in for Apache Hive.
Okay.
Yeah. Again, but that book also do not have all these details. That's a very basic written books because that was their demand from Cloudera, that they want the book which is very basic in nature to start with. And then there will be another book which will come as an advanced Hive. Advanced big data and Apache Spark, which I'm already working on. And again, I'm kind of co-authoring. I'm not the alone author. There's one more author who is from US, who is also kind of giving, and he's also very experienced. In fact, he's more experienced than me. He's almost 20-year experience in this domain, and he's pretty good. So basically, that second book will be having all these optimization concepts.
Okay. So I just wanted to understand, like, what was the thought process that went into when writing this book? It is purely based on the experience, right? That you got over these years.
Yeah, actually, if you ask me how that happened, I was giving a training to Cloudera. And that's where they sort of came up and said that, hey, it looks like you have a lot of experience in this domain because you have worked in open source and all. Whether you will be interested to kind of talk about your knowledge in form of a book, because we also have a lot of books materials which we sell off. And that's how this whole thing started. Means I have never given this thought. This thought was imposed on me from Cloudera and I liked it, so I went ahead with that. So the other co-author is from Cloudera only.
Oh, okay. Good, Shivan.
Are these books internal to Cloudera or do they sell them?
They will be selling it. So you will find a lot of books from Cloudera, right? I think they have a tie-up with Orally. If you know this Orally part, they have a lot of books, right? So you will be
Yeah.
fine. So the first book I've already given to them. They're just refining it or whatever. I don't know. Second book. So for us, it's like you just take one chunk of money and go. It works like that. Then you should not be bothered what we are going to do with that.
So Shivank, I think we can wind up the session. Like at 9, we have another meeting with our CEO.
Yeah, I
So
start the project today, because I think a lot of time we spend it to understand this optimization techniques. Everyone clear? Any questions? We still have 5 minutes.
Yeah, Shivank. Yeah, we have 5 minutes. I quickly wanted to get a summary on the optimization techniques. As far as my understanding is concerned, we can broadly divide it into 3 categories. First one is based on the engine or the framework, which we can define as stage or LLAP based on the scenario. Second is the file format, isn't it?
Correct.
The third technique is not very clear to me when you talked about vectorized operations. So that will be something related to processing within those prescribed engine. Say within Tej, we can identify which, if we can go for vectorized technique or what. This part is not very clear to me.
So it doesn't matter which framework you're using. This is independent of
Across. Okay.
You have a column C1, which have, let's say, an age. Maybe let's say age column. Maybe you have like 28 age, maybe somebody have 30 age, and so on. Let's say it's a huge data. This is just one column out of it. Now, what we said that, okay, this data became 2 years old. I should add +2 age to everyone. So in that case, if you write a simple Hive query, what it will do, it will say, it will go 1, it will say 28 + 2, go to row 2, will compute 30 + 2, and so on, right? Means if I talk about, let's say, one data node operation, how it's happening. So instead of that, if you vectorize it, what will happen? It will increase the parallelism. So it will say that, okay, let me create a batch, maybe of, let's say, size 20. Create a batch of 20. And I know that I have the codes to support 20 parallel execution. So what it will do for 28, 30, for all the other rows also, for 20 rows, it will hit that +2 altogether in one step. So let's say if one operation used to take 0.2 millisecond. So now to complete that 20 things, you will still take only 0.2. So can you see a save of time here?
Yeah. So it processes, first of all, based on column level, it divides, and then batches within the columns.
So because it's performed that batch thing, that's the reason it makes the thing faster. And you are not bothered about those parallelism and all. It will automatically take care.
Automatically. So all this is defined using commands, vectorized, ORC. Okay.
Just like I showed you, this set hive.execution.engine is equal to LLAP, right? Similarly for vectorize also, there is a command like set hive.vectorize dot something. I'm just forwarding that. I can give you the exact one. Is equal to true. That's it. When you will enable that true, it means that the vectorize enabled. Now the next operation, whatever you're going to perform, will be a vectorize operation.
And all this will hold good for a particular session, right? If I set the engine to LLAP or Tej, that holds good for a particular session.
Correct.
When I log out, it is defaulted.
Definitely. It will be again defaulted to MapReduce.
Okay.
Okay. But like I said, never use MapReduce. If you are doing that, it's wrong.
So if we have to like put it in ascending or descending order, like at high level, it will be MapReduce, then Tej, and then Yan maybe, and then LLAP.
We should not say that. That will be a wrong way to say. If you have a batch query, go for your Tej. If you have interactive attack query, go for LLAP. Then I also explained you that how you can have both together, where let the Hive decide that, okay, if it's an interactive query, send it to LLAP. If it's a batch query, send it to Tej, right? We have also discussed that. So
yes,
that also something you can do, which I've already explained you that setting as well.
Understood.
Okay.
What was the full form of ORC again?
It was optimize row column.
Yeah, that's all. Thank you, Shivank.
Yeah. So any other question? Hey,
Shiva,
would like to go through this recording because I think I was taking your name and you were not there at that time. since you had told me that you were using Impala, just go through that execution part. You will get an insight that how you can remove Impala and still stick to Apache Hack with little better performance.
Okay, Shivank.
Shiva, can you make today's and yesterday's notes available somehow? Maybe in the shared drive or somewhere?
This same notes which I've written down, because I don't have any notes as such. I can give you this.
Yeah, that's fine. Yeah. I meant to say the queries from yesterday and today.
Code I have it because I
Yeah,
did
what you have. Yeah, exactly. Like in the class. Yeah.
it before your class itself, so I can pass it on in your Google Drive.
Right.
So tomorrow let's connect for the same time, 7:30 to 9:30. Maybe on Saturday we will increase it by half an hour. Then. Okay. Sure.
Thank you, Shivank. Bye.
Thank you, Shivang.
Thank you, Shiva. Bye.
Yeah.